So good morning, my name is Leyi Jiang or Lucy Jiang, and I'm going to present you a topic, engineering the compassionate solution to air pollution. So let's start from talking about the air pollution in China right now. I was a leukemia survivor. So I had leukemia when I was 10, it's in like about 2010. And after 1 year of chemotherapy, I survived, but after a year later, the air pollution became really severe in China. It's about like 2012. And I just suddenly feel like the difference in the air. And I was sick all the time, like for half an year. And that's why one of the reasons I came to US. And like from that incident, I just realized how important the air quality is to people's health and to people's living standard. And that's why I decided to do something to help people in highly polluted areas and to help people around me. And I just started my research. And I discovered that air purifier is one of the key factors that can help us relieve this problem at house. And I discovered something very shocking, which is first, air purifier is a typical premium product, which means that the company just set the price artificially high for the product, and it's not good. It's, for example, like in China, the cheapest air purifier is about like $150. It's not cheap for like everybody, especially for those people with like lower income. And this product, air purifier, should be everything. Should be like everyone should have, but they are like pretty expensive that no one can afford it. And although like people realize pollution is a serious problem in China, but they ignore the importance of household purifiers. Why I said that? Because of the graph there. The universalization rate of household air purifier, which means like the percent or like how many people of the total population in China have purifiers, is about only 1% in China comparing to other countries. So like here, from left to right, that's Japan, is 17%, US 27%, Europe 40%, and Korea 70%. And for China, it's only 1%. And China is where it has like the most serious pollution problems there, and it has like the greatest population, but we have like the lowest rate of having purifiers. And my goal is to create a sustainable air purifier system containing like a software that can make this purifier affordable for everyone and make it like environmental friendly for everyone. So first, I started simple. I disassembled a lot of purifiers from different companies. Very stupid, but simple. So like this, I broke it into 3 parts. First, filter, fan, shell. Simple, very simple, shocking simple. So first, you put a fan in the shell to make it stable, and then you put a fan on the top or by the side of the purifier. So like the dirty air can blow in, and it just comes out through the filter as a clean air. And then I started my basic design. So first, I chose the filter from Me company. It's a Chinese company. It produces a very cheap but good quality of filter. It's here. And I designed the shell with the fan in accordance with the filter. You can see the size is 400 by 240 and 240 millimeters. And I chose the programming system, which is Arduino, because first, it is a programming platform that have like all the function I need for the purifier. And then it uses languages C and C++, because I taught myself in like the auto programming, so it's very easier for like beginner. And I bought all the additional stuffs on internet, thanks Amazon. And it's here. I'll talk about them later. And I designed the program is there, so it's auto programming. So let's start from lithium battery. One of the reasons that makes the purifier special is because without a power source or without electricity, it still can work for like 5 hours because of the lithium battery that can store energy. And then the energy goes to the control board for charging, which is this can like transport all the electricity and energy to the whole system, different part of the system. And then it goes to the driver. The driver is what makes the fan move. And then big thing Arduino control board, which acts like a brain for the system. So it tells what like all the things can do. And it has two main functions. First one, we have a dust sensor here. So it tells the dust sensor to detect how dirty the air is in the air. And then it will transform it into a data called like PM 2.5, which is a very common concept in China, which is like how many particles are right now in this room that are less than 2.5 micrometers. And the data will appear on the LED screen. The second step is it will, the data that the sensor collected will go directly to the fan and makes the fan move at a different speed. So I made the fan works in like 4 different levels of speed. So when the air is dirty, it works with higher speed and vice versa. So 4 levels of speed. And then we have a breadboard here. As you can see, there are a lot of wires here with different colors. So I'm a messy person. I don't like to organize things. So the breadboard is only for organizing the wires. And then we got a switch here. So the switch is like act like a lamp switch. So like when you click on it, the whole system is on. And then we got a booster here. Why I had booster? Because first, the working voltage of the battery is 3.7 volts. But the working voltage of the fan is 12 volts. So I need a booster to boost from 3.7 to 12 in order to let the whole system match and move. And then we got a solar cell here, and I will explain that. So like in order to make it more environmentally friendly and cheaper for the people, I wanted to add a solar cell to the whole system. So that even though if you're in like desert or you're in a very poor area without electricity, it still can work if you like put it under the sun. And I encountered some problems. When I turned on the whole system, when I like built it like successfully, I discovered there are like some noises in the fan that are very loud and annoying. But I had like no idea about what's happening. So I just came out to my dad and said like, "Oh, my dad, my God, there's like noise in the van. What should I do?" And my dad said like, "It's only vibration. Calm down, kids." So like a typical way to solve this problem is add a capacitor. After trying different types of capacitor, I found out like the 330 microfarads is the right one for the problem. And done. I got the purifier, and I named this the purifier system as the combined air purifier system, CAPS, fancy. And then I named it Hello World Air Purifier, because I want my purifier to act like me, like wake up every morning, turn it on, and just like see the world and say like, "Oh, my beloved world, hello." And for the project, I held a concert for raising the money for the project. And then in the concert, I also raised a campaign to like raise people's awareness toward like the issues in China right now. And I successfully assembled 9 purifiers. I donated 6 of them to like the kids in Shanxi, China, which is a very highly polluted area. And that's me in the concert, and that's me in the campaign. Some more thoughts. So I'm going to college next year. A lot of people ask me like, "What's your major? What are you going to do next?" I said engineering. And their response is also like, "Engineering? That's rocket science. No, that's way complicated for me." And I said, "No, it's not the case. I'm just normal. I'm just like an ordinary girl like everybody else. I struggle with school. I struggle with losing weight, but I can do this. If we just pay attention to like all the little things around us and just spend more time not like glancing through Instagram, but just working on something, everybody can do engineering. Science and engineering should not be something that is complicated, but it's something for everybody." So the end. Hello world, make our world a better place.
You were, that's a really interesting question.
Thank you.
That's great. Is there, in your methodology, was there a way of determining the overall improvement of air quality in the room?
Yes, so like I tested after I built like the thing. So like first I determined the card number or the card value, CARD number of the purifier, which is like how much air, clean air it can produce in the room. So it's about like 150 meters cubed in an hour. So like it can produce 150 clean air, like meter cubed clean air in 1 hour. So, and I tested with like several different things like smoke, like something like toxic, and it does work.
And you were able to discern from that measurement a discernible improvement in the air quality within the room?
Yes, with like all the smoke and all the like the toxic things, I just put it like by the purifier, and I tested this the number on the screen change, this like the smoke goes to anywhere like that. Yeah. Thank you.
Okay. Fascinating. So thank you very much. I'm curious, you showed us one design where you decided on the circular filter, right?
One design.
Yeah, the picture, what you
This one?
No, a little back further.
Sorry, a lot of things.
The actual filter, this one.
Oh, this one. Oh, yes.
You said this is the one I selected. So I'd like to hear a little bit more about how you decided that was the filter you wanted to use in your experiment.
Okay.
Was it a square or an oval, or a triangle, or
Okay.
some other model?
Yeah. So like how it looks is not the important part. I chose it because mainly it's cheap. It's one of the cheapest in China right now, but it has a good quality. Cause like I'm a student, I'm not a mass producer. If I'm a mass producer, I would use like a better filter. But this one is the one I can find is the best for my project. Cheap, good. Yeah.
Okay. So it wasn't that you tried different other cheap filters. You just knew this was the cheapest and most available.
Yeah, and actually I have like several cheapest, like several like that is like cheap but not good quality based on the information.
Okay.
Yeah.
Great. Thank you.
Thank you.
So I love this. How many iterations did you have to go through before you found the final product? You know, you were in a lot of soldering. Did you know how to solder before you did this, or did you solder all that?
I did it all on myself, and it's painful at first. Yes.
A lot of burned fingers.
Yeah, I spent a year last year. So when I was in junior year, I did all things, all like the putting together, and finally in summer break, I finally made the products. Yeah.
And what was the final cost?
It's about $60 per purifier,
$60.
but if it goes into mass production, it will be a lot less. Yeah.
I have just one more quick question. I'm fascinated that you gave instructions to the fan of only 4 levels
Of speed, yes.
How did you choose 4 versus some other number, 3 levels or 5 levels?
Personally, first I like for this number, and I set the data. So you know, like the PM 2.5 is like the number, so it converts into a number. So like from 0.0 to like 0.5, it works at this speed. So I just divide into 4.
I see.
Yeah.
Very good. Thank you very much.
Thank you.